Good afternoon and welcome to today's SaferSim webinar. My name is Jacob Hayden and I'm a program coordinator for SaferSim at the University of Iowa. SaferSim, or Safety Research Using Simulation, is a Tier 1 university transportation center with the research priority of promoting safety. Our webinar series features the research taking place within our center. Thank you for joining us today. Before we get started, I would like to point out the chat box in your Adobe Connect window in the lower right-hand corner. So please use this chat box for any questions or comments, and there will be time at the end of the presentation to address these questions. So now I'm pleased to welcome our presenters from the University of Puerto Rico-Mayagüez, Didier Valdés, and from the University of Massachusetts-Amherst, Francis Tainter. And Didier, I am turning it over to you.
Well, thank you very much, Jacob. I really appreciate the opportunity to present this webinar. Welcome to our webinar. I hope that everyone is staying safe and healthy. We will present the result of our SaferSim project entitled Speed Behavior in a Suburban School Zone, a driving simulation study with familiar and unfamiliar drivers from Puerto Rico and Massachusetts. This is a SaferSim collaborative project between the University of Puerto Rico and Mayagüez and the University of Massachusetts-Amherst. At UPRM, the research team includes Professors Didier Valdés Diaz, Alberto Figueroa Medina, and Benjamin Rios, and the graduate research assistants Maria Rojas and Enid Colon. At UMass, the research team includes Professor Michael Nodler and the graduate research assistants Nicholas Campbell and Francis Tainter. Okay. This is also a collaborative presentation. I am Didier Valdés, and I will be presenting on behalf of the UPRM research team, and Francis Tainter will do it on behalf of the UMass research team. In terms of our agenda, our webinar starts with an introduction to a research problem and objectives. We will briefly introduce the driving simulators used in this project. Then the main tasks developed in this project will be presented, from experimental design to data analysis, and that will lead us to our main conclusions and recommendations. In terms of the introduction, according to our highway safety data, pedestrian deaths amount to a high proportion of the fatalities in our highway system. Looking at the numbers related to pedestrian fatalities in our highways, almost 6,300 pedestrians died in 2018, which is the most significant number since 1990 in the US. Puerto Rico is among the 10 jurisdictions with the highest pedestrian fatalities, where almost 37% of the total road fatalities were pedestrians in 2018. And safety for teenagers in the US has also been critical in school zones. Kay and other researchers reported that there were 5 teenage pedestrian fatalities in this project. We studied school zones with significant interaction between drivers and pedestrians, with issues related to the possibility of distracted children crossing the street and drivers speeding along the school zones. So in terms of speeding and familiarity, I can say that several school zones in Puerto Rico are located in areas adjacent to major traffic generators and major arterial streets. In our study, we explored the lack of compliance with speed limits in school zones that has been identified in previous research as a critical safety issue. The main issue that we explore in this research project is the familiarity with the roadway environment. This is also a topic that has been found as an essential aspect of human factors. Therefore, we developed this collaborative project in which local Puerto Rican subjects were tested in Puerto Rico using a school zone and roadway scenarios that are familiar for them, and test subjects in Massachusetts driving on Puerto Rico scenarios that are not familiar for them. considering that Puerto Rico receives more than 2 million tourists per year, and many of them drive on our highway system. Our interest is to find out how drivers that may be unfamiliar with the driving environment perform compared to local drivers familiar with the driving environment. We have two scenarios that consider the current signage and the proposed signage with a prominent overhead sign that compels drivers to reduce their speed in the school zone as an innovative approach to reduce speeding and also eliminate pedestrian injuries and fatalities in our highways. Well, in terms of the objectives, the main objectives of our project are first, to evaluate drivers' behavior related to speeding in school zones for both familiar and unfamiliar drivers. Second, to evaluate the effectiveness of enhanced traffic control devices on reducing speeding behavior and increasing speed limit compliance. And third, to test if there are significant differences in performance between drivers familiar and drivers unfamiliar with the roadway environment. So let me tell you a little bit about the roadway environment and its characteristics in terms of current speeding behavior, geometry, and signage. One of the studies performed in the school zone selected for this project was a speed study. As you can see in this slide, only 10% of the drivers comply with the 25 miles per hour speed limit. Definitely, speeding is a problem in this sector. In terms of a roadway environment approaching the school zone, this slide shows a picture of the current geometry and signage of the school zone selected for our study. Let me emphasize that the signage follows the standards and guidance provided by the Manual on Uniform Traffic Control Devices, are known as MUTCD, in terms of shapes, sizes, and placement. However, the legends are in Spanish according to the Puerto Rico's Department of Transportation manual. We continued using Spanish when making our experimental signage. As you can see highlighted by the red arrow, in Puerto Rico, the yellow transversal line represents the first point of the school zone. This pavement marking conveys the message along with the roadside sign highlighted on the right of the slide. This sign includes a speed limit regulatory sign of 25 miles per hour with the supplementary yellow top plaque with the word escuela or school, and the supplementary white bottom plaque indicating the specific periods that the special school speed limit is in effect. Let me introduce now an overhead sign that was selected as the best alternative to improve speed compliance in a previous Safer Sim project performed at UPRM that we would like to test in this collaborative project with familiar and unfamiliar drivers. This new sign, tested in the simulation scenarios, is an overhead sign that includes an indication that this is a school zone with the words school zone in green, zona escolar, when the speed limit or velocidad máxima applies when lights are flashing or con luz intermitente. The school zone speed limit in this case is 25 miles per hour, that is indicated there, and the sign is complemented with flashing beacons to emphasize that drivers should comply with the special school speed limit when the lights are flashing. The signage is complemented with a roadside sign, school zone sign, plus pavement markings indicating the beginning of the school zone with the word escuela across each lane. Now let me introduce Francis Tainter from UMass, who will continue with our project. presentation. Go ahead.
Can you hear me? Okay. I'm assuming audio is working?
Yep, I can hear you, Francis.
Perfect. All right, so thanks, Didier. Now I just want to talk you all through the kind of methodology and the process that was undergone for the study. Again, as Didier mentioned, this is a collaborative project between both University of Puerto Rico and Mayagüez and us at UMass. And you can go to the next slide, Didier. This next slide, this just shows you a quick screenshot of the two simulators that were utilized in this study. So on the left, you have the non-full cab 3-screen projection driving simulator that is down at UPRM. And then on the right is the full cab simulator that we have at UMass. Again, both of these simulators utilize the RTI driving simulator software, and those were utilized for this study. Next slide. So this is the breakdown of the research methodology. Again, on the top right is a quick screenshot of the actual location that was being modeled in the simulator. So again, as Didier mentioned, there was a literature review that was done. There was a selection process for the location. And once that selection process was completed, the base scenario was developed in Google SketchUp. And then it breaks down into the experimental design, which I'll get into in a minute. And the data collection foils into the two groups, which is familiar drivers and the unfamiliar drivers. The familiar drivers being those at UPRM in Puerto Rico, and then the unfamiliar drivers, which were conducted in the driving simulator at UMass. And then we'll get into the statistical analysis and some of the conclusions and recommendations. I do want to note that the majority of this project was undertaken by Maria and the folks at UPRM. We helped a lot with the running of subjects at UMass, but the majority of this project was definitely handled by our folks from UPRM. So next slide. So again, the Samuel Adams School, which is pre-K through 9, has the enrollment of about 900 people. It has, so the main strip of roadway, PR2, that it's located on has that high ADT volume, which makes for some unique safety challenges. Being a major arterial with 45 mile per hour roadway speeds, although that school zone segment has 25 miles per hour, quote unquote regulated, there obviously are some challenges given the design of the roadway itself, as Didier alluded to previously. Next slide. So this just gives you an overview of where this is located. So again, it almost looks like a major arterial when you look at this high-speed roadway with a school adjacent to it. And you can almost make out that line of cars, the pickup and drop off on the lower side of that road as they approach the entrance and that pedestrian bridge to the school itself. Next slide. So again, I think these pictures tell the story itself. You have this major arterial and you have these cars picking up and dropping off and almost double parking at some points. You have, people standing around waiting for pickup. It causes some potential safety issues. And so that's kind of the whole reason why this project kind of came to fruition. So trying to take these pieces and investigating them in the driving simulator is the major objective of this project. So I think we can go to the next slide. So overall, looking at the experimental design of this project, it kind of foils into these 3 different levels. So built into 12 total scenarios, it first breaks down into the pedestrian variable. So looking at at the point of the school, looking at an adult with a child on the side of the road, scenarios where there are no pedestrians present, and then only scenarios where there are only children present on the road. And then you pair this with that next variable, which is whether those vehicles are parked on the shoulder or not. So yes or no, so whether those vehicles are present. And then lastly is just the presence of ambient traffic on the roadway to begin with. So whether vehicles are with the flow of traffic or not. So that was the 3rd level of variation here in the experimental design. And again, 2 groups of 36 subjects were recruited. So 36 participants were run in Puerto Rico and 36 participants were run in Massachusetts. Next slide. And you can see that we had this select age group. So we wanted to focus on age as a demographic, within this study. So looking at the age range of 18 to 25 with younger drivers, the middle-aged population, 26 to 45, and then 46 and above, and then splitting that evenly amongst males and females. Again, this was split evenly for both locations, so both in Puerto Rico and Massachusetts, 36 subjects each, even split of male and female, and even split amongst the age demographics as well. Next slide. So this is the basic signage configurations that were built. So like it was alluded to on configuration 1, that is the existing condition. So it has that horizontal yellow line built into the pavement to mark the entrance and exit of the school zone. The technically non-compliant yellow school zone sign, then the simplistic school zone speed limit and time of day when it should be considered, and then again the ending school zone horizontal line. And then configuration 2, so having school written on the pavement itself in text, the compliant fluorescent yellow-green signage, and then this new speed limit sign, this overhead flashing sign that Didier was mentioning earlier, with the school zone with the fluorescent yellow-green, and it has a little bit more flair to it with the flashing signals left and right. And then importantly too is that end of school zone sign, the S5-2 at the end. And if we go to the next slide, it kind of shows the breakdown of where these were located. Yep. So essentially, in doing the analysis, the roadway segment was broken into 5 zones. So 0 through 4. On the left here is configuration 1, which is the existing condition. And on the right here is that condition 2, the proposed, if you will. And so, zone 0 is considered free flow conditions. So prior to the school zone, this is when the vehicles are at free flow. And then conditions 1 through 4 each break down where those new or existing signs were placed. Zone 3 being the location of the actual school itself. So right prior to that pedestrian bridge, that's where we had the vehicles present on the side of the roadway and or the pedestrians on the side of the roadway as well. Next slide. All right, so getting into some results. This is a little bit of an overwhelming graphic to look at to begin with, but I can break it down really easy. So this is just looking at the mean speed behavior from zone 0 and zones 3. So zone 0 being free flow conditions, so prior to that school zone, and zone 3 being, like I just mentioned, at that spot right as you approach the school where either the pedestrians were present or not and the vehicles were present or not. So this is simply looking at unfamiliar versus familiar drivers in configuration 1 and configuration 2, and it's looking at that mean speed behavior across these 2 zones. So there is significant differences observed for configuration 1 with the existing traffic control devices, but there's even more of a difference for configuration 2 with these enhanced traffic control devices, and you can kind of see that with these highlighted red values on the righter half of this table in configuration 2. So it just highlights that there's some significant differences between we're calling it the difference, which is that mean speed between the unfamiliar and the familiar drivers, which is the main highlight from this table. Next slide. This is a really cool graphic. So this shows kind of the driver's reaction to the presence of the pedestrians, specifically traversing from zone 2 to zone 3. So this is specifically taken from just, I believe, scenario 12. So this is showing where there is a pedestrian present at zone 3, and it's really showing that change of speed with the presence of that pedestrian. So on the left side, we have the unfamiliar drivers, aka the drivers from Massachusetts who don't experience this very much, this type of environment. They're they have, they have more of a consistent speed across zone 1, 2, and then at zone 3, you can see that dip in speed as they approach zone 3 with the presence of, pedestrian right on the shoulder there. And then on the right side, you see a little bit more of a consistent decrease in speeds across zone 1, 2, and 3. There are slight dips, as you approach zone 3 on that side, but overall, there is the most unique takeaway from this slide, I think, is the fact that zone 3, you can see how much of an impact those pedestrians have on the drivers with that significant sharp decrease in speed, as soon as they see that pedestrian on the side of the roadway. Next slide. And so this is a breakdown of overall speed compliance between configuration 1 and configuration 2. So again, configuration 1 being the existing setup with the current traffic control devices in place. So on the left side here, we have unfamiliar drivers and familiar drivers, and it's basically just showing the percentage of those who complied with the speed limits in both zone 0 and zone 3. So zone 0 being free flow speed, where the speed limit is raised to, I believe it's 45 miles per hour at free flow as a speed limit set. And then zone 3 being the school zone, where it's limited to 25 miles per hour. And so overall, there is a trend that zone 3 or the familiar drivers rather, are more compliant in zone 3, meaning that as familiar drivers approach the school zone, they are more likely to comply and lower their speed to that threshold of 25 miles per hour. And then on the right side here in configuration 2, you see pretty much the same story. It's pretty similar with the updated traffic control devices in terms of speed compliance. But again, with the unfamiliar drivers, there is still a higher percentage in certain locations of a greater compliance with the unfamiliar drivers, which I think is what configuration 2 is really going for, to make sure that those people who are visiting are still complying in these types of locations and areas, and providing that extra sense of safety mitigation or potential speeding mitigation at these locations in particular. So next slide. So lastly here we have an interesting view of the mean reductions in speeds. So again, same old, we're looking at the unfamiliar drivers, those from Massachusetts, and the familiar drivers are those from Puerto Rico. And we're just looking at the mean reductions from zone 0, free flow speed, to zones 3, which is right by the school at the location of the pedestrian bridge just before. And this is showing just the overall mean reduction in speed. So like it says at the bottom here, 67% of the scenarios, these configuration 2 TCDs did have the anticipated effect. So essentially almost all, 2/3 of the time, these updated TCDs were reducing the speed of those unfamiliar drivers, like I was alluding to on that last slide, which is, kind of important here, right? We want, as many opportunities to reduce the speeds of these people who are visiting, and they're not as often of those who are, typically compliant. And so that, I'm going to transition it back over to Didier, who's going to wrap up with some conclusions.
Thank you very much, Francis. Well, conclusions. I'm going to highlight a couple of aspects that we found to summarize our results. In terms of speed behavior, we can conclude that the combined effect of text in Spanish and the overhead sign with flashing beacons used as enhanced traffic control device is not necessarily apparent to familiar drivers. The signs follow ME2CD colors and size, but the text is in Spanish may have not been understood by unfamiliar drivers. From our school zone experiment, it was found that familiar drivers do not show significant speed reductions. The reduction was observed in the case of unfamiliar drivers reacting to the presence of pedestrians. close to the arterial street main lanes. And in terms of speed compliance, we found that by providing information in a clear and more visible way, it is possible to reduce speeding and crash severity. Our proposed traffic control device configuration showed a 30% improvement for familiar drivers and up to 11% improvement for unfamiliar drivers, which is good for these kind of devices. And in addition to that, unfamiliar drivers also improve in terms of speed reduction. However, the compliance was between 0 and 16%. So for familiar drivers, the main reduction in speed was lower than familiar drivers. However, the compliance was much higher, between 30 we understand that these findings contribute to the discussion of improving the safety of pedestrians, particularly additional learning strategies should be considered to improve compliance of the drivers. So I would like to acknowledge and thank the team on the program, Department of Transportation, and all the extraordinary people listed here that help us complete this project from both universities, University of Puerto Rico and Mayagüez.
But thank you, Didier and Francis, for the presentations. We do have a few minutes now for any questions or comments, so feel free to type that in the chat box if you have anything. I will point out that thank you, Didier, for including this contact information on this slide. So if you do want to follow up with this study, you do have some individuals you can reach out to directly by email. I will also include the link to the final report for this project if anyone is interested in checking that out for more details. And I'm not seeing questions. So with that, I would like to thank everyone for joining today and your interest in our SaferSim research. This presentation will be online on our SaferSim YouTube channel and website within the next couple days, and we will send that to you all by email as well when it's ready. And then look out for our next flyer for the next presentation, which will be Tuesday, July 21st. And that is more research from the University of Massachusetts-Amherst. So look out for that. All right, thanks again, everyone, Didier, Francis, and all the attendees. Look forward to seeing you at future webinars. Thank you.